We are looking today at compound interest, how it works. We're looking at a very simplified version so that in our next lesson we can delve a little bit deeper. Our prerequisite skills we're relying on, nice and simple, your ability to handle changing from a percentage to a decimal and back. Nice and straightforward. Now this lesson is suitable, frankly, for anybody looking into annual compound interest. You might be in grade 9, you might be in grade 10, you might be in grade 11 or 12, whenever you are going through this exploration. Now, we'll start off. You are borrowing $100 from a friend, and you offer to pay 6% interest every year for 10 years to borrow that money. Now, if you're borrowing this money from a friend, this 6% interest, really you're looking at 6% of 100. Now, in math, the word of means multiplication. So 6%, which we know how to write as a decimal, is 0.06. So 6% of $100, well, that's going to be working with 0.06 times 100. I could throw that into my calculator. I end up with $6. So really, if we're working with simple interest, which is nice and straightforward, if we're working with simple interest right here, it just means that you're paying $6 every single year to borrow money from your friend. That means that for the first year, after the first year, you owe $106. After the second year, we're adding, and there, sorry, we added $6. If we add $6 more, we're working with $112, nice and easy. We add $6, we're working with $118 after year 3. And how we could jump to year 10 is we could say, well, hang on, from year 0 to year 10, that's 10 years of borrowing. If we're borrowing this money for 10 years, we're adding $6 10 times. We're working here with 100 plus $6 times 10 years. That is 100, remember, because we're following our BEDMAS, plus $60, and that is $160. Fantastic. Nice job, us. Now, the way compound interest works is instead of paying that $6 every time, what is happening is you're saying, well, you know what, because you haven't paid me this $6 yet and you're paying it at the very end, then it's almost like you're borrowing this $6 too. So every single year, we're no longer just collecting interest on the $100, we're also collecting some interest on the $6 as well. Now, if that's the case, the way it works, we're working with $100, that's what we begin with. And into our second year, we will have this $100, plus we'll have this 6% interest. Now, really that means is that $100 is owed, that's 100 times 1. Plus, there's another 6% that's owed. So that's really 106% that's being borrowed after the first years. So I could just multiply those together. $100 times 1.06, I throw that into my calculator, I end up with $106, nice and straightforward. So far, there is no difference between our simple interest and our compound interest. Here's where it changes. Now, going into this second year, how much is being borrowed is that same number from before, 100 times 1.06. And what's going to be new is now we're borrowing it for another year. So we're going to multiply it by 1.06 again. I could rewrite this if I want to. I could write this as 100 times 1.06 squared, because really squaring something is just multiplying it twice. So I can throw this into my handy dandy calculator, and I end up with $112.36. $112.36. Now you'll notice, very small difference, just a 36-cent difference after 2 years. Okay, so let's take a look. Let's see how this continues if we're borrowing this money for one more year. That is, we still have borrowed $100. After the first year, we multiplied it by 1.06. After the second year, we multiplied it by 1.06. And for this third year, brand new, we're multiplying it by 1.06. Because every year, we have that 106% here. So I could rewrite this because I am used to working with powers. I'm working with 100 times 1.06 to the power of 3. If I throw that into my calculator, I'm working with nice and easy $119.10. Hopefully at this point you can see the pattern that we've come up to, right? Because working with the first year we had 106, working with the second year, and really, working with the first year we had 100 times 1.06. The second year, 100 times 1.06 to the exponent 2. Third year, 100 times 1.06 to the exponent 3. Following this pattern so that I don't need to multiply by 1.06 every single year, I can say, okay, we're working with 100 times 1.06 to the power of 10. That's after 10 years. When we're throwing this into our calculator, we need to make sure we follow our BEDMAS. So we will first evaluate 1.06 to the power of 10, and then we'll multiply that by 100. Now, I will show you the calculation here so that you can confirm this. You can double check so that you know you understand how to work with exponents in your calculator. I'm ending up with, I'll keep my original 100 times 1.06 to the power of 10. Once I throw that into my calculator, I'm working with 1.79. All right, then I'm multiplying those two together, and I'm working with $179. So the difference here after 10 years, if we are working with compound interest versus simple interest, is $19. Now, it might not seem like a lot. The difference changes depending on how long we're borrowing the money, and the difference changes depending on how much money was borrowed. I'm hoping you've been able to recognize our new equation that we're working with right here, and I'll bring it down. Number one, we're going to call the amount of money that we begin with, or that's being borrowed or invested, P for principal. So the principal amount in this case, the money that was being borrowed, was $100. Number two, we're going to call A the amount of money, and A, the amount of money you end up at the end of the investment. Either that's the amount of money that you now own, or if you were the one borrowing, that's the amount of money that you now owe. The R is going to be our interest rate. Now that is going to be measured per year. We will play around with that a little bit more when we explore our compound interest a little bit deeper. And our T is the amount of time that we're investing for. This is going to be measured in years. Okay, if I look at all of these letters and I look at our equation that we came up with before and I try and put them together, then what it is that we're calculating is A. That's the final amount that we're looking for. And I can put final down here if it's helpful. The final amount that we're looking for, either borrowed or owed. The principal amount is the $100. That ends up right here in our equation. And then we're multiplying this, by 1 plus the interest rate. This was measured per year, in this case with 6% per year, and it's given as a decimal. I want you to make sure you're comfortable with that. And then at the very end, we put this to the power of the number of years that we're investing to the power of T. This is our brand new equation. This is an equation that you will use as you're working through problems like this. We can take this equation, we could isolate for our p-value. If instead we knew how much money we needed to have after investing for a certain amount of time, and we're not sure how much money we will need to invest today in order to find a future value, then the way we can write this equation is instead by dividing both sides by our brackets over here, we end up with the new equation P equals A divided by 1 plus R to the power of T. These are your brand new equations. I encourage you, use your BEDMAS, try out these brand new equations working in your practice problems. Nice work.